Our client C++ application creates C arrays with some model data and uploads this information to the graphics card. So if this is the buffer of memory that we have in our graphics card, these C arrays are uploaded to that memory. So once there, the shader declares input variables, and generally speaking, all of these arrays of data we refer to as vertex attributes. These input variables inside the shader are considered to be read-only or constant values, and every vertex with all of its attributes gets processed with this input to these input variables inside of our vertex shader. There may be some limitations on how many of these input variables you can have, but you need to check with your version of OpenGL to see the actual limit. So typical examples of vertex attributes are vertex positions, basically geometry of our objects, the normal vectors, which are supplied with every vertex, texture coordinates, which are also associated with every vertex, the colors. This may be optional if we start using the textures, and also other things that you like. Uniform variables, like we have them over here as well. So these uniform variables, typically matrices and also vectors, have to be set once per every frame that you'd like to paint on the screen and make it all visible. So the client program first needs to query the unique identifiers of uniform variables inside a compiled shader, right? So we make a query, so we obtain those unique identifiers, and then using these identifiers of these uniforms in our shaders, we call GL uniform with different suffixes corresponding to the data types, and we pass the information and we set them up. So each matrix gets set up like this. Each vector that we want to specify, all of this information is passed by this call to OpenGL, and then as individual vertices are processed, right, for every triangle, when the vertex program executes, these uniform variables are all the same for every vertex. They don't change, and they have to be treated as constants in our shader. They cannot be updated or modified. When rasterization happens and our geometry is broken to individual fragments, and then each fragment is passed to our fragment shader, at that stage all of these uniforms are still available in every fragment shader. So it remains the same for every vertex, and it will remain the same for every fragment that gets processed by the fragment shader program. And uniform variables like these matrices are extremely useful to pass all of these 3D transformation parameters to our vertex shader, because this is the same for every vertex. All vertices pass through the same set of transformations.